Welcome to Dementia Matters, a podcast created by the Wisconsin Alzheimer's Disease Research Center. It's our goal to humanize Alzheimer's research so that our community, our patients, our participants, and anyone else interested can get a better understanding of the work that's happening to fight back against this disease. My name is Nathaniel Chin, and I'm a geriatric memory clinic physician at the University of Wisconsin. I'm also the family member and son of someone with dementia. I'll be serving as your host for this podcast and asking the questions I believe are in the minds of many in our community. Thanks for joining us. Today on Dementia Matters, I'm with Dr. Brad Christian, a UW professor of medical physics and psychiatry at the University of Wisconsin School of Medicine and Public Health. He is the director of the Weizmann Brain Imaging Laboratory and leader of the Molecular Imaging Core at the University of Wisconsin Alzheimer's Disease Research Center. His research focuses on developing new brain imaging techniques to study neurodegeneration and cell death in the brain, and he's an active researcher in the field of Alzheimer's disease and Down syndrome. He is the principal investigator of the UW site for an international multi-center study that is investigating neurodegeneration in aging Down syndrome, also known as NIAID. Well, welcome to Dementia Matters, Dr. Christian.
Well, thank you for allowing me to come and talk to you today.
I'd like to start by asking, how did you get into this field of Alzheimer's disease as it relates to people with Down syndrome?
Well, my research was already very active in the field of Alzheimer's, working with Dr. Sterling Johnson using positron emission tomography or PET imaging methods to track changes in the brain during the course of disease progression or even the pre-disease condition. So that work naturally folded in nicely with the research that we were conducting at the Weizmann Center, which focuses on studying neurodevelopment all the way through neurodegeneration associated with intellectual and developmental disabilities. And we had very active research programs going on there in Down syndrome. So this work was a perfect complement of the research interests that we had at these two excellent centers present at the University of Wisconsin.
I see. So you started in two places. You were doing Alzheimer's disease research with Dr. Johnson, but then you were also doing separate research at the Weizmann Center dealing with the other spectrum of neurodevelopment.
That's correct. So that research focuses on developing PET methodologies and techniques to primarily measure changes in neurochemistry. That is, PET imaging uses different labeled drugs that we can study in tiny quantities in the brain to track potential changes in chemistry during the course of development or neurodegeneration.
And what is it that you're studying, or what is it that you're finding?
Well, first, let me give you a little bit of background on Down syndrome. So Down syndrome is the most common genetic developmental disability, present in about 1 in every 700 births. It's also referred to as trisomy 21 because people with Down syndrome have 3 copies of chromosome 21 rather than just 2 copies of each of the 23 chromosomes typically found in the nucleus of the cells in the body. So this additional genetic material results in alterations during development that we see in Down syndrome. So it's a genetic dosing effect, if you will. Now, the connection of Down syndrome with Alzheimer's disease has only become evident over the last several decades. This is due to the dramatic increase in life expectancy of people with Down syndrome, a result from advances in medical procedures such as cardiac surgery, but also better access and standard of care for the Down syndrome population. So whereas children with Down syndrome born in the early part of the 20th century had a life expectancy of about 9 years, this has now increased to individuals living into their 60s today. And we are now observing the incidence of diseases that accompany aging in the general population, with Alzheimer's disease being a very prominent one.
So you are now seeing people with Down syndrome living longer than before, and because of that, you are seeing more diseases associated with being older in this population. So are you seeing most people with Down syndrome developing Alzheimer's disease, or are you simply picking it up sooner than in a population that has a longer lifespan?
Well, that's a good question. What we believe right now is the source of pathology. It's somewhat different between the Down syndrome population and what I'll call the general or non-Down syndrome population. So people with Down syndrome are developing dementia at a much younger age and a much higher incidence. In the general population, the prevalence of Alzheimer's disease increases more rapidly for people in their 70s or 80s. However, in the Down syndrome population, this same increase corresponds to when people are in their 40s. And as people live into their 60s, the overall prevalence of dementia is almost 80% in people with Down syndrome.
It's not believed to be the same cause of Alzheimer's disease as in people with Down syndrome. Do we have an idea of what their mechanism is?
Well, the current theory links it back to those 3 copies of chromosome 21 and the potential of producing a higher level of proteins that are implicated in Alzheimer's disease. And we know that one of the signature features of Alzheimer's pathology is the presence of these plaques, or more precisely, beta amyloid plaques, coating the brain's neurons. These plaques are aggregates of a protein called beta amyloid precursor protein. And one of the genes responsible for the production of this protein is located on chromosome 21. So it's hypothesized that cells with 3 copies of chromosome 21 will produce an excessive amount of beta amyloid and result in a buildup of amyloid plaques in the brain.
So in our research center and in many across the country, we are spending a great deal of effort looking at these biomarkers, these amyloid plaques, in research participants. Is the same true in the NIAID study or in the Down syndrome population? Are you looking at amyloid beta as well?
Yes, so this is very similar, but this is the same amyloid that we're imaging for the other studies. It's believed to be the same amyloid as we would see in late onset. So it's thought that the development of Alzheimer's disease accompanying Down syndrome may be more related to an overproduction of amyloid, as opposed to a lack of amyloid clearance that may accompany late onset disease in the general population. So it is still the same disease pathology, however, perhaps it's different mechanisms with how they accumulate to greater levels in the brain.
And so in these studies, you are also doing PET scans and lumbar punctures. You're assessing the same way we do in all of our other populations.
Yes, that's right. So many of the tests that we're conducting are identical to those that are being done in the aging general population. In fact, our entire study was designed with that in mind. We wanted to, as much as possible, mimic the exams that were being acquired in, for example, the ADNI studies, Alzheimer's Disease Neuroimaging Initiative. We tried as much as possible to match the collection of this biomarker data as is being acquired in that study so that this would serve as a comparison to the general population too.
So then is it fair to say your overall goal is very similar to the current research studies that are done in late onset individuals?
Yes, I think to a large degree. So our goal is to investigate the changes in amyloid as well as the other biomarkers, including the presence of tau pathology related to neurofibrillary tangles in the brain, and then those markers that are present in the CSF as well as the blood. So we want to see how these changes in biomarkers relate to changes in cognitive function in the Down syndrome population. This type of study is a natural history study. That is, we're just observing changes in the individuals. By carefully monitoring when these changes in the various biomarkers occur, we hope to capture the relationship between their decline as well as the decline in cognitive function to see if we can better understand the relationship between the changing measures.
So in essence, before we can make a clinical intervention, before we can change the course of disease, we really have to understand what it is. And in order to understand it, you're using biomarkers and relating those findings to what we see in a person, the clinical tests, the medical history.
Right. So these types of studies, yes, are very similar to all the ones ongoing in the general population. So we just need to track these biomarkers, which we strongly believe are related to the pathology, that is strongly related to the causes of Alzheimer's disease, and hopefully define some type of window at which these changes match with decline in clinical function and where we're seeing a decline in cognition. Once we've characterized that, now we can start to better inform the intervention trials and see when the ideal time would be to potentially still salvage function, still salvage the cells that are living in the brain yet, that have not succumbed to Alzheimer's disease.
Your team, just last year in October 2017, published a study called Cognitive Decline and Brain Amyloid Beta Accumulation Across 3 Years in Adults with Down Syndrome. Now, for our listeners, could you explain what you were looking at and the interesting findings that you had?
Yes, so in that first study we conducted, our primary biomarker was looking at amyloid burden in the brain using the PET techniques. And in addition to that, so we performed longitudinal scans. That is, over the course of 3 years, we would have the people come back and scan them again to measure changes in the presence of amyloid in the brain. But at each visit, we also had them undergo the cognitive tests that I had mentioned earlier. And what we had found, we classified them according to individuals that we would call amyloid positive, that is, those that had significant increase in the PET tracer, and amyloid negative, those that had none. And we found in the amyloid positive group, we saw a greater decline in cognitive function in some of the memory and learning tests. So that would suggest that perhaps the amyloid is having some type of effect on function in the brain. However, we really have to approach this interpretation with caution, because also amyloid tends to accumulate in the brain as a person gets older. So we are still closely examining the data to see if indeed these decreases in cognitive function were related to increases in amyloid or perhaps just due to the natural aging process. And that is why this current study we have ongoing, we've increased the number of people with Down syndrome that we're going to be studying up to 180. So we will have very large numbers and hopefully be able to more carefully separate the effects from the presence of amyloid and that due to just natural aging.
What is the future direction in researching Alzheimer's disease in people with Down syndrome?
Well, our hope is really to use the information from this natural history study of simply collecting data to understand how or when Alzheimer's disease develops in people with Down syndrome, and actually transition the study into a prevention or an intervention trial, where we would put strategies for preventing or at least delaying Alzheimer's disease into action. Once we have characterized the trajectories of changing brain chemistry in place and understand how this relates to changes in clinical function or cognitive decline, then we can use these data to inform how a treatment study should be designed and to answer questions like what would be the optimal time to introduce a therapeutic drug, or what levels of biomarker should we attempt to intervene, or did this drug hit its target and result in a reduction, for example, say amyloid in the brain. Now, the all-encompassing goal of this study with people in Down syndrome is no different than the other biomarker studies in general population that track the course of changing processes relating to Alzheimer's disease to better understand treatment trials, particularly in different genetically predisposed at-risk populations. But because the prevalence of Alzheimer's disease is so much greater in people with Down syndrome, implementing treatment trials in this population will allow studies to be conducted with fewer people. helping to reduce the cost of treatment studies, which, as you know, can be in the hundreds of millions of dollars. And also because people with Down syndrome have a faster progression towards developing dementia. Treatment trials with Down syndrome may provide answers sooner.
Well, thank you, Dr. Christian, for coming on and talking with us today on Dementia Matters, and we hope to have you back in the future.
Well, thank you for having me.
Dementia Matters is brought to you by the Wisconsin Alzheimer's Disease Research Center. The Wisconsin Alzheimer's Disease Research Center combines academic, clinical, and research expertise from the University of Wisconsin School of Medicine and Public Health and the Geriatric Research, Education, and Clinical Center of the William S. Middleton Memorial Veterans Hospital in Madison, Wisconsin. It receives funding from private, university, state, and national sources, including a grant from the National Institutes of Health for Alzheimer's Disease Centers. This episode was produced by Rebecca Wazaleski and edited by Zoe Rugel. Our musical jingle is Cases to Rest by Blue Dot Sessions. Check out our website at adrc.wisc.edu. You can also follow us on Twitter and Facebook at Wisconsin ADRC. If you have any questions or comments, email us at dementiamatters@medicine.wisc.edu. Thanks for listening.